uncertainties. Pause the video now and try all 4 questions. So question 1, it's quite simple. It's asking for the absolute uncertainty in this measurement. Absolute means as a number. So we obviously need to work out 1% of this. So that's really easy to do. And we will get this as an answer. Now, you might be tempted to write 45.3 plus or minus 0.453, but that would not be the most correct answer. We can only measure this value to 1 decimal place, and the uncertainty on that is plus or minus 1%. So our best answer should really be 45.3 plus or minus 0.5, and then whatever unit it would happen to be, to show that it is that 1 decimal place that we're measuring to. Question 2, so here we have to do 2 things. We firstly have to work out the resistance, so that's really easy, V divided by I, so 30.0 over 3.65, which gives us 8.22 ohms. I've chosen to write it to 3 significant figures because both of my numbers are to 3 significant figures as well. What is the uncertainty? Well, I have something divided by something, so I need to add the percentage uncertainties. So that's really easy to do now. I can work out the percentage uncertainty for this. I look at this decimal place here, and then that is the smallest division. So my absolute uncertainty is 0.1, and then as a percentage, it is this. I'm going to add the percentage uncertainties because it's this divided by this. So I can add that to the percentage uncertainty for this, and we notice we can measure to 2 decimal places, so the smallest division, 0.01, times by 100. So this first one is the percentage uncertainty in V. This one here is the percentage uncertainty in I. So we plug that into our calculator, and we get our answer as 0.04992. So my final answer is going to be 8.22 plus or minus 0.05 ohms. And again, I've chosen to round this to 1 significant figure or 2 decimal places is probably the best thing to say, because again, my answer here is 2 decimal places. I can't measure beyond 0.01, so I therefore cannot write my uncertainty to any more than that. Question 3 is asking us to work out the acceleration. So we know that acceleration is change in velocity over time. So I can work out my actual value for acceleration by just plugging in these numbers, which is obviously 5.5 over 2.8, which gives us 1.96 meters per second squared. Now my uncertainty, I've got 2 things that I need to do. I have to recognize that I have something minus something, and I have to recognize that I have that divided by something. So the uncertainty in V minus U, when we have something added to something else, we simply add the 2 uncertainties together. So the uncertainty for this is plus or minus 0.1, the uncertainty for this plus or minus 0.1. So the uncertainty is 0.2 meters per second, because if both of them were 0.1 higher, then the true value of this subtraction would be 0.2 higher or lower, and if one of these was lower and the other one was higher, etc., you would go the other way. That I may not have explained that super well, but you know, just think about the upper and lower bounds of adding 2 things and subtracting 2 things. So the uncertainty of V minus U is this. Now we have something in the form A divided by B, because we have 5.5 divided by 2.8, so we're going to add the percentage uncertainties. So we have the percentage uncertainty in this, which is 0.2 over 5.5 times by 100, plus my percentage uncertainty in this, which is 0.1 over 2.8 times by 100, which gives us a percentage of 7.2%. We then need to calculate that, turn that back into an absolute uncertainty, so turn that back into a number, and we end up with this for our value of acceleration. Now, if you put this, again, it's not the best possible answer. All our values here are to 2 significant figures, so we shouldn't really give our answer to 3 significant figures. So a better answer is to write our answer to two significant figures and then our uncertainty to the same level of resolution, so one decimal place in this case. Okay, finally, question 4. Density is mass divided by volume, so that is 6.380 divided by, you might be tempted to put 20, but we always need to look at the units. Kilogram per centimetre cubed is not really a standard unit. We should have it in meters. So this is 0.200 meters. So 0.200 cubed. That is our density, which is 798 kilograms per meter cubed. So 3 sig fig, 3 sig fig, 4 sig fig. So this is the lowest number of sig fig, so we should probably give our answer to match that. What is our uncertainty? Well, we've got something of the form A over B times C times D, because volume is length times width times height. So we need to make sure our uncertainty to this is added to this, added to this, added to this. Now, because obviously these are the same number, it's the same as multiplying it by 3, just to save a tiny bit of writing out. So the uncertainty is going to be the uncertainty in my mass as a percentage plus 3 lots of my uncertainty in my length, which is this times 100, which gives us a percentage uncertainty of 1.5%. Now I'm going to convert that back into a number because it did say absolute uncertainty. So my final value of density is 798 plus or minus 12 kilograms per meter cubed.